Alrighty, welcome to Subnetting Part 1. I'm your instructor, Pete, Packet Loss Manglaviti. No, I really don't have a nickname, I just thought I'd throw one in there, and Packet Loss seemed like it was appropriate. I want to talk a bit about subnetting. We're going to go ahead and go back through some basics, and then just try to work it up a bit. Go through Class C's, take a look at B's, A's, supernetting, and just things that you might find real world, and also on the Network Plus and Cisco exams. So we got a lot to do. Here we go. So let's start off with the Class C IP address. So I'm going to draw a little C here. And we know a Class C address by the number in the first octet. So for example, if I'm looking at an IP address such as 192.168.30.7, we identify it to Class C by this first octet. Remember, it doesn't matter what the mask is, it's always the first number that matters. The first number specifies the class. And we know the default subnet mask is a 255.255.255.0. Okay, so what is a subnet mask, just for some review? Well, subnet mask separates which portion of the IP address is the network, which I like to think about as the last name, and which portion is the host, which I like to consider the first name. So for example, if we had 3 people, I almost drew stick figures. I'm going to hold off on that. I draw really, really bad. And let's say, for example, the people, let's say their names were the following. They were Brown, Jim, Brown, right, last name, Jill, first name, and then James, Jim. Now look at those 3 names. Which 2 are most likely to be related? Again, I said most likely. Is it the 2 people with the last name, Brown, or 2 people with the first name, Jim? Now you might be saying, of course, it's Brown. If 2 Jims run into each other in the middle, in middle of Times Square, they don't go, oh, Jim, you must be my brother. I mean, it doesn't go like that. But my last name being Manglaviti, if I run across another Manglaviti, they're probably family. Probably family I haven't heard from in a while. I'm going to hold back the tears. So again, the idea is this, that the last name dictates the network they're part of. Well, this works exactly the same way in terms of IP addresses. We take a look at these 3 numbers, the 192.168.30 and 7. We need to figure out which portion is the last name of the network and which portion is the first name, which is the host. The quick way to do that with a default subnet mask is simply to take a look at the last 255 and draw a line. Just like this. The stuff on the left is the network, which is the 192.168.30. The stuff on the right of the line is the host. Now this rule breaks when we change the defaults around of the subnet mask. But if it's a default mask, you just go after the last 255 and draw a line. Okay, so with that in mind, let's take a look at an example of this. Let's say we had the IP address of 200.1.2.3, and we had another IP address of 200.1.3.4. And we're trying to determine if these guys are on the same network or different networks. So step 1 is identify what class it is. Well, 200 is a Class C. Next thing we need to do is put down the default mask for a Class C, which is 255.255.255.0. Next, we draw a line after the last 255. Bam. Bam. Now I sound like that guy, what's his name, Emerald. Bam! I needed my own catchphrase, like whoosh. That's what I'm going to say. So we separated the 2. Remember, the left side's the network, and the right side's the host. Now, look on the network side. Are the numbers exactly the same? In other words, are they exactly the same? The answer is no. So it's almost like saying one person's name is Smith and one person's name is slightly different, like Smithy. Notice that although the names are similar, they are not related. So we need some type of layer 3 device, such as a router, to move data between them. They're on separate networks. So we want to make sure that concept rings true. After the last 255, you simply draw a line and draw another line. Now, check this out. What if I change this? Let's get rid of that 0. Right? And let's say these machines are 20.1.2.3 and 20.1.3.4. So the first thing you notice is this is not a Class C anymore, is it? It's a Class A. Next, my mask is wrong. For a Class A address, it's 255.0.0.0. And now look, after the last 255, we draw a line. So the divider line drawn right here. Right there. Notice to the left, that's now the new network. And these numbers are the host. So if I change it to a Class A, notice that both networks start with the number 20. They're on the same network now. Okay, let's go through a Class C example. So let's say, for example, you're given the following IP address, 192.168.50. In other words, you get the full range, .z, you get the whole range. And somebody comes to you, your IT manager, and says, look, I need you to break up this one big network. Think of a network as like a building, like a whole building. And each office in the building is what we call a subnet. What that means is, in an IP world, is one range of IP addresses is the broadcast domain. If we want to break that up into pieces, we create what's called subnets. So your IT manager says, look, we need to separate this out into at least 5 networks. So, for example, without subnetting, 50.1, 50.2, 50.3, 50.4, blah, 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 50.200, they're all on the same network. However, when we break this up into subnets, we're basically putting people in different offices. So, for example, 192.168.50.40 and a 192.168.50.90 might not be on the same network anymore. It's up to us as admins to figure this out. So let's take a look at the process. My method is basically just a hybrid of everything I've seen out there and what makes sense to me. I like to cut through the BS and just lay it out. How do we get what we need? So here we go. I draw a T-table. And I label the left side network, the right side host. Does this T-table look familiar to you? It should, because in the last example, I did this. 192.168, something similar to this. I put down the subnet mask, 255.255.255.0. We did this, and we labeled it. Guys, this right here is the same thing as this. Okay? Same thing. So the stuff on the left is the network, the stuff on the right is the host. Let's keep going. Draw another line. We're now going to put a formula on both sides. Right now, just draw the formula out. As we move on in the series, I'll talk about more and why it works the way it does, if you don't figure it out before then. So on the left side, we're going to go ahead and put a 2 raised to the nth power. And on the right side, we're going to put a 2 raised to the nth minus 2. So just to kind of run through this again, 2 raised to the first power is 2. 2 to the second is 4. 2 to the third is not 6. Remember, it's 2 to the third is 2 times 2 times 2, which is 8. 2 to the fourth, 2 times 2 times 2 times 2, which is 16. Keeps doubling, 32, 64. Please keep that in mind. I notice that's a problem sometimes when students are doing these problems. Make sure you stick with the powers. Now draw another line. I want you to draw a circle on the left and a circle on the right and a circle right above the H. These are going to represent bits. This was something I came up with because sometimes I would have a number such as 3 on the left and I would say, oh, 3 networks. But it wasn't 3 networks, it was 3 bits needed for the networks. So the circles were basically a, subnetting for dummies for myself, to remind myself these are not how many networks or how many hosts, it's the bits involved. It'll make more sense in a minute. Then to even enhance the dummies book, I went ahead and added a Pac-Man right here. Because yes, I grew up in the 80s. I was pretty good at this game. And I drew a Pac-Man. And then I labeled the right side as net. And the right side is hosts. All right, and so the cool thing about this, and why I love this method, you're thinking, yeah, I know why you love it, because it's your hybrid. No, what I love about it is because it really makes it simple. If you work in a Class A, the setup is the same. Class B, the setup's the same. Class C, the setup's the same. It's the same thing. You don't have to keep memorizing different kinds of patterns. So memorize this. For your exams, write it down on your whiteboards when you're, right before you test, and you have that couple minutes on that first question. Put this on your notes if you take like a Network Plus exam or Cisco. It will take some of the pain later on. Okay, it makes life a little bit easier. Okay, so let's solve this problem real quick. And what we want to figure out is how many networks and how many hosts. So here we go. So I'm asking for 5 networks. Does that mean we're working on the left side or the right side if I ask for net and networks? Yeah, the left side. So 2 raised to what number gives me at least 5 networks? It doesn't have to be exact, but it has to be at least. I mean, think of this. You're in a building and you need to build at least 5 classrooms for students. If you build 6, you have a little bit left over. But if you build 4, there's some people going to be pretty upset because they have nowhere to go. So you want to always build at least that many. So all we do is we ask ourselves, 2 raised to what number gives me at least 5? 2 raised to the first is 2. I'm actually holding up fingers right now. You can't see me, but I'm doing fingers. 2 raised to the second is 4. 2 raised to the third is 8. So 3 bits were required to give me at least 5 networks. Now what I'm going to do is over here where the hosts are, I'm going to go ahead and put the number 8. And what that reminds me of is, of this problem, 192.168.50.z, meaning everything, all the numbers in the hosts, that 8 of these bits are for the host. Because remember, every single one of these numbers represents 8 bits. I'm going to do a little bit of binary review in either part 2 or part 3. So if each one represents 8 bits, it means one of these numbers, right, this number right here, number 4, is 8. As you can probably guess, as you change the classes, the number of bits for the host changes. Okay, now here we go, complex part. You had 8 bits. If that's difficult, you had 8. For Pac-Man, we had 8 pellets. We ate cookies. I don't care what it is. Pac-Man ate 3. How many left over? 5. 3 plus 5 has to equal 8. If that works, you're balanced. Last step for this first phase. We simply do this. We plug that number in, the 3, for n. We plug the number 5 in for n on this side. So 2 raised to the third power, 2, double it, 4, double it, 8. That means we have 8 networks. And now 2 raised to the fifth, 2, 4, 8, 16, 32, minus 2, 30. That means we're able, in order to satisfy this problem, the 5 networks, we can give 8 networks with 30 hosts per network. It works. Now, what our next steps are to do is to figure out what the new subnet mask looks like, so the computer knows what we know, and then figure out the ranges. What IP address ranges are in the first network? Which ones are in the second? Which ones in the third? I hope that makes sense. It was good talking to you guys, and I'll see you in part 2.